A certain mass of hydrogen is changed to helium by the process of fusion. The mass defect in fusion reaction is 0.02866 atomic mass unit. What is the energy liberated per AMU? Given 1 atomic mass unit is equal to 931 million electron volts. The mass defect given is delta M is equal to 0.02866 AMU and 1 AMU is nothing but 931 MeV. To calculate the energy liberated per AMU during the fusion reaction, we use Einstein's mass energy equivalence relation given by E is equal to delta mc square. But delta M is the mass defect in atomic mass unit. We need to calculate energy liberated per AMU of the system. Let's first calculate total energy liberated. The total energy released due to the mass defect can be calculated using the formula E total is equal to delta M into 931 MeV. Substituting the given values of delta M, we get E total is equal to 0.02866 into 931, which is nothing but 26.68 MeV. Let's find energy per AMU. The reaction involves the conversion of 4 hydrogen nuclei, which are protons, into 1 helium nucleus. Therefore, the mass defect corresponds to 4 nucleus. And to find the energy liberated per AMU, we divide the total energy by the number of nucleons involved. So we get E per AMU is equal to E total divided by 4. Substituting the calculated total energy, we get E per AMU is equal to 26.68 by 4, which is nothing but 6.67 MeV. Thus, the energy liberated per AMU is 6.675 MeV, so the correct option is option B.